So, good morning, everyone. We have another lecture on our series. Today, we're privileged to have Dr. Judith Estep with us from Bonneville Power Administration. She's the Chief Technology Innovation Officer there, and Bonneville Power is a part of U.S. Department of Energy. I'm going to let her introduce herself further and also talk about her topic, and I'll share the presentation now.
Thank you. Perfect. I can see that. So yes, thanks for the introduction. I am Judith Estep and have worked at Bonneville Power for 10 years. And the last 2 years have been spent as the Chief Technology Innovation Officer. And looking at the date on that presentation, I can't believe that it's almost been 4 years since my defense. Time flies. But really, I'll give you maybe some background on what motivated me to pick this as a research topic. So 2005, Bonneville Power started a research program, and it was an effort to really centralize all of the research efforts that were happening at BPA. And Terry Oliver, my predecessor, was the one who established the program, the Technology Innovation Program. And we get to do all the fun stuff, really, at BPA, test new technologies to help out the transmission, distribution, or the hydroelectric power system. Lots of very interesting projects that we've worked on since 2005. And Terry did a phenomenal job of putting the program together. And it's really centered around developing roadmaps as the basis for our research, and then picking a portfolio, managing that portfolio, and having a technology transfer aspect as part of the overall framework. But when I started there, I would say that there was definitely maturity with Dr. Daim's help and other students at PSU in the areas of road mapping and portfolio management. I started there as the project management officer, so my responsibilities were around managing all of the research projects and working with the subject matter experts. But we also had, like I said, technology transfer was a part of that original framework, but we didn't have a good method or process for managing technology transfer. And so I felt that if I'm doing research, it would benefit BPA most if I could help to put that framework, that process for managing technology transfer in place. And so that was what motivated me to look into technology transfer for my research topic. Next slide, please. Dr. Daim, could you advance the slide? Thank you. So these are the areas that I'll talk about. So the introduction will serve as sort of the background, again, more motivating reasons for doing this research, what the overall objective was and the gaps that I identified through my literature review, how I was going to carry out my research and the results of my research and the analysis, and what the conclusions were and the limitations of my research, how this is contributing to not only benefits at BPA, but how other organizations could use it as well, and discussion of some potential future research topics. Next slide, please. So not only was it important for me to understand how we could do better at tech transfer with the research projects that we were focusing on at BPA, there are a number of other government organizations that invest a significant amount of money in research. And they do basic research, and it's intended to sort of fill that pipeline for development and going from knowledge transfer into actually application of results. And in some of these areas, the technology transfer part was seen as a significant challenge, not only from, well, primarily from bridging that chasm between the actual research results and how do we get them applied so that we can realize the benefit of those results. So what I'm showing here is some of the investments that are made by the National Institutes of Health, National Science Foundation. EERE is the Energy Efficiency and Renewable Energy arm of DOE. The California Energy Commission, and ARPA-E is Advanced Research Projects Energy. And what's not shown there is BPA. And at the time of this research, our investment was about $15 million for research projects. But I would say that none of these organizations really had an emphasis on how to apply or had a process for how to apply the research results. Next slide, please. So this is just another way of looking at the different research organizations, what their mission is, and what criteria they found to be important as part of the proposal process. And so, Dr. Diamond, I can't see the bottom part of the slide. Is it possible to scroll up at all? Thank you. Yep. So, but what's, like I said, it is the tech transfer part of research. These organizations did not have an emphasis on it when you look at their proposal criteria, except ARPA-E, Advanced Research Projects Energy, and they required that 5% of the R&D budget for a project was allocated to technology transfer activities. So they had to start thinking that the groups that were submitting proposals, they were required to dedicate some of that budget to how they're going to manage, how they're going to think about tech transfer as part of the research effort. But it didn't describe what that process should be or what things they would be looking at. It was just very generally defined as dedicating a portion of the budget. So an improvement, but there still needed to be more to better define what that process looked like. Next slide, please. So there are lots of reasons to look at research and development and the failures and the need to do research. I'm showing them here. But just because you invest in research does not guarantee that you're going to, A, be successful, and even those projects that are successful, no guarantee that those research results are going to be applied. And the reason for that, and in the projects that I'm showing here, is that technology transfer seem to be an issue with getting those research results applied. So that is a motivation for me doing the research. We have good research results. How can we do better at making sure that those results are applied and the organizations realize the benefit of their investment? Next slide, please. So I looked at, like, my initial start was to look at how is technology transfer defined. And there are a number of different ways that it could be defined. Knowledge transfer, it could be commercialization. It has been described in literature as relationship building. It's that discussion between the researchers and the people that are going to apply the results and making sure that there's that connection so that the organizations that are going to apply the results are ready to receive them when the research is complete. And then there was a lot of discussion in literature about who are the players in technology transfer. Still forefront in my mind, even from when I've done this research a long time ago. I recall PNNL's definition of tech transfer as a contact sport. It's definitely, you have to be very active, actively engaged in the research and communication. So I think it aligns best with that relationship building piece. But I would say that in general, how organizations define technology transfer very disparate, and it depends on the organization. So it was important to me to, at the beginning of my research, to understand how I was going to define technology transfer for, in the case of this application, how technology transfer is going to be defined at BPA. Next slide, please. So this is how I am describing technology transfer, is that it's a relationship between the researchers and the people that are going to receive that technology, and it is a continuous effort. And I don't, what I'll show later is the relationship building does not start once the research is complete. Technology transfer has to be considered throughout the research process and even at the very beginning when you're developing a proposal and when you're actually developing the project plan. So for the purposes of, I'm sorry, could you go back? Thank you, sorry. So yeah, for the purposes of my research, tech transfer was understood to be application of a technology from a research partner to a utility in this case, with an emphasis on building that relationship so that that chasm is going to be easier to bridge. Next slide, please. So we're moving on into my research objectives. And so I identified and showed that when organizations are evaluating a research proposal, they don't even consider technology transfer or attributes as part of the review process. And so I wanted to develop a technology transfer score that can be used at the very beginning of a research topic idea, so that it can be used to evaluate our research and development proposals. Next slide. So my literature review, again, I started with understanding what the requirements were at different funding organizations for considering technology transfer. And then I did a considerable literature review, comprehensive literature review on what were the attributes that are necessary for having a successful technology transfer. And then what methods are out there for analyzing tech transfer. And then again, the funding organizations, how do they evaluate research proposals, and how could they include technology transfer success attributes? Next slide. So this is the start of the literature review. Identified that technology transfer should be a very important part of the research and development selection process. So again, research suggests that technology transfer, the things that you have to start considering, don't wait until the end of the research to think about it. Make sure that partners are engaged from the very beginning. Next slide. So I looked at different taxonomies of how to organize technology transfer, success attributes, and thought about the organizing them around different perspectives. So a lot of the literature talked about how an organization contributes to successful tech transfer. There are definitely some technological aspects. There's that social component, and then there's the market. And in this case, the market is considered those who are going to actually receive and be recipients of and use the technology. So the people that are actually going to apply it. So I organized the results of my literature review into these different perspectives. Next slide, please. And so I combined them into the market attributes, social, technological, and organization. I did, like I said, an extensive literature review to identify the 21 success attributes. And again, literature very strongly emphasized that it's a relationship between the researcher and the technology recipient. that's important for successful tech transfer. Over and over, that was a resounding theme. Next slide, please. So for the methods for analyzing tech transfer, there were some strengths and weaknesses that were identified for each of the different methodologies, but it was clear that there was not a methodology that provided a quantitative, inclusive, or prioritized the assessment factors that I identified in my literature review. So all of this is kind of coming together for building a model that could be used to analyze research proposals as part of the evaluation process. Next slide, please. So this, I looked at the individual proposals, their evaluation criteria along the perspectives that I identified. And I looked at the several research organizations that I discussed at the very beginning of this presentation. So the California Energy Commission, they don't have any organizational attributes that they consider as part of their proposal evaluation, nor do they have social attributes or market. ARPA-E similarly has none of those, and the EERE, NSF, or NIH don't either. All of the primary emphasis of their evaluation for a research proposal is on the technological aspect. So despite the literature saying that tech transfer was necessary at the beginning of an R&D proposal and the selection process, I propose here, submit here that there's a lack of emphasis on including those success attributes when you're evaluating the criteria. So I wanted to develop a way to make sure that those success attributes were considered as part of the research process. Next slide, please. So the literature summary, it's an important part of the selection process. The methods that are used to look at tech transfer don't provide a quantitative or prioritized assessment, and that there is a lack of emphasis on technology transfer success attributes in the proposal evaluations. Next slide, please. So this led to my research gaps, which I just previously stated. My goal was to develop an assessment model that will enable these organizations to look at successful technology transfer potential as part of their evaluation criteria. And so some of the things that my research addressed were, is the proposed framework appropriate for assessing tech transfer? Or some of the questions, some of the questions that my research was going to address is my framework appropriate for assessing tech transfer potential? What are the most important attributes out of the 21 that I identified? How can we prioritize them? And really understand, okay, if this model that I'm developing is going to be used, what level of effort is required to implement it as part of the research evaluation process? And then importantly, I wanted to see if the model was technology agnostic. So could this be applied to really any technology in any organization? Next slide, please. So this is just an overview of how I was going to go through my research. So I did the literature review, I identified the gaps, and then that led into really developing the model and identifying experts, having them validate my model, quantify it. And then I used desirability curves to help better refine the perspectives and success attributes in my model. And then once my model was complete, I needed to test it on something. And so I had a great opportunity to use some of the research proposals at BPA. So they were used as a case study. And then wanted to know the sensitivity of my model So did an analysis. So again, I wanted to make sure that it was technology agnostic and make sure that it was robust enough to be used in any organization. And then I did the analysis and looked at what conclusions did I come up with and recommendations for implementation. Next slide, please. So the methodology that I chose to use was a hierarchical decision model, and it was appropriate for this type of analysis because I was dealing with multiple variables. So here we are with the different perspectives and the 21 success attributes organized under those perspectives. Had lots of people that were going to be part of the analysis to make sure that it was robust enough and could be used in any organization. HDM allows for sensitivity, and HDM allows for doing a sensitivity analysis to confirm the generability of my model. So I started with my mission, my objectives, goals, and alternatives. Next slide, please. So this just goes to further show how I was going to develop the hierarchical decision model for my tech transfer score. Next slide, please. So I had to definitely get experts to validate my model. Does it look right? Is there anything else that I need to consider? And then they were also part of the quantification piece. So the experts that I used are shown here. They need to be representative of their organization and what I'm trying to test in my model. And experts are important because they provide they bring to the analysis their expertise in that area and how technology transfer is applied practically. And so looked at their education as part of the identification of who would be good experts and how they engaged in their research, what their relevant publications were, and then forming the expert panels. The recommendation was to have 10 to 18 experts per panel, and then I needed to make sure that I was aware of how I was defining them, the characteristics, their backgrounds, and being able to form them so that they could address different aspects of my model. Next slide, please. So this is the expert panel was going to also be used when I did the quantification piece. I made sure that I looked at the consistency among the experts' response and that there wasn't any disagreement within the group. So those are very important criteria to use. If there was a big disparity, I needed to go back and do different analysis, but as you'll see, the results were that the experts were very consistent in their responses, and there was no disagreement in their responses as a group. Next slide, please. So I was fortunate enough, and I certainly encourage my students and other committees that I am on, it's easiest to find a topic and then therefore have access to experts if you can find something, if you're working and if you can find something that would be applicable to the organization that you're in, because you have a wealth of experts at your disposal. And so I was very fortunate in that regard, that there was a need at BPA to understand technology transfer, and that really gave me access to not only people at BPA, but within the industry, utility industry, to be part of my evaluation team. So I had access to 54 experts. And I wanted to make sure that my model was robust enough and generalizable. So I just didn't want to focus on a utility. So the organizations that were represented by these 54 individuals are utilities, there are nonprofits, research labs, so the national labs were very accommodating in my request, universities and consulting company, and the 54 participants were distributed among executives and R&D management positions. There were lots of project managers, there were subject matter experts, and people that I grouped into strategists, so they had this big overarching picture of the R&D effort. And so for each of the different areas of going through my model and quantifying it and first qualifying it, making sure that it was an appropriate representation of technology transfer attributes. And then they were also used to quantify my model. And so I'm showing here in the chart how I distributed those experts within the different areas or the panels that I was using them for. Next slide, please. So the first step was to do content validation. So asking them to look at the success attributes that I identified and asked if the different perspectives that I had organized these success attributes were appropriate. And so I did a Survey Monkey to collect this information, but I also reached out to them and had discussions to make sure that they understood the questions that I was asking of them. If they had any feedback, so I was able to collect verbatim feedback from them. And so I feel that that's a very important part of the validation piece, because you want to make sure that what you are communicating is heard by those experts that you're asking to respond. So my criteria for understanding if my perspectives were correct and if the way that I assigned the success attributes were correct, and were there any other success attributes that I needed to consider. I needed to make sure that all of the people that I asked for each of these different sections agreed within greater than 67%. So maybe one of the panelists had a different idea, but I needed to have at least 67% of the respondents say that, yep, these are good perspectives and these are appropriate success criteria, and no, you don't need to add anything else. Next slide, please. So I talked a lot about the 21 success attributes and the different perspectives that they were organized in. So this is my final validated model. So I have the 4 perspectives, which are organizational, technological, social, and market. And within each of those perspectives, I've identified different success attributes. And so then I would develop an overall tech transfer score that could be applied to different research proposals, as shown in the level 4 model, in the level 4 of this model. Next slide, please. Now I got into the actual quantification of my model, and the literature review suggested overwhelmingly that the market was necessary for successful technology transfer. And if you recall from the research proposals, the chart that I presented at the very beginning with the different organizations and what they considered as part of their evaluation process, they focused on technological. They focused solely on talk to me about that technology. And here we're showing, based on the respondents' quantification, that it is consistent with what literature is showing us, that they believe that the market was the most important part. The overall weight of that was 0.39. It was the most important perspective when considering technology transfer. The next important was the actual technology itself, followed by social attributes, and then the organization attributes was the least important, but not much difference between that and the social aspect. So my experts agreed with what the literature was telling us, that creating that market pull was a necessary component and the most necessary component for successful tech transfer. Next slide, please. So then I went through and did the same for the success attributes within each perspective. So what I'm showing here is the highest weighted or therefore most important perspective. And then within each perspective, what the experts said were most important. So in the market perspective, it was a close rating for the level of top management interest. So making sure that the executive stakeholders on the receiving end were engaged as part of the tech transfer process and the research process. And then that there was a big importance placed on what's the return on investment for this research. The next important was technology. And then within technology, describing what those benefits are most important. But again, that goes back to, or that relates to the market piece. So what are the benefits? They need to be identified so that the market can understand and have that tech transfer pull. And then within the social aspect, having project meetings was identified as the most important success attribute. And then under the organizational perspective, technical and stakeholder complexities was most important. So those are further subdivided into technical and stakeholder complexities within the subdivision were equally, but basically you had to make sure it was better. Tech transfer was identified as being, the potential for tech transfer was identified as being more successful when you had a less complex technical project, and that you had stakeholders involved, but the fewer stakeholders involved, the better. Next slide, please. So then I used desirability curves to further refine and understand each of the success attributes. And so this concept is tricky to understand in that I remember another thing that stuck out was understanding desirability curves. We use the analogy of hamburgers. And so basically, if you are starving and you haven't eaten for a week and you're presented with 100 hamburgers, that first hamburger is going to be very desirable to you. You're starving. And that second hamburger, it may be as equally desirable as you, but at some point you're going to start to feel full. And so the value of that last 100th hamburger is probably not going to be very valuable to you. So translating that into my success attributes, how valuable, what is the importance of each one of them, and developing a curve where it's most important, or whether where the value of that success attribute drops off. And I use the subject matter experts, my expert panels, to help me develop these desirability curves. And I'll show you examples of these on the next slide. So thinking about the hamburger analogy and then transferring it to the desirability curves for my success attributes, I'll give you an example of the geographic proximity. So geographic proximity was identified as one of the success attributes, and it's the distance between the researcher and the technology recipient. So I organize, so the y-axis is how important is it to be close to the researcher and the tech recipient, be close together. And then on the x-axis, I broke it down into segments of a range. So my expert panels thought that there was most value in my researcher and the tech recipient being within 10 miles of each other. And then if they're greater than 3,000 miles, so it is a international project that you're working on, that is least preferred out of the proximity between the researcher and the tech recipient. You're going to have your most challenges here, and that's understandable. That makes sense when you're working on an international project. Next slide, please. So now that I have my model validated, I have it quantified, how am I going to test my model? So I needed to use really a real life example. So I chose to use examples in the utility space. And it's important because at the time, you know, we had a significant amount of money going into, through the Recovery Act, a significant amount of research going into renewable energy and integration. And part of that included research related to demand side management. And then there was a significant amount dedicated to identifying energy efficiency technologies. And so it was important because utilities are risk averse. And so they want to make sure that the technologies that they're testing, they're going to work. And so it was, from that regard, that's why I thought it was important. So the Recovery Act, and to help utilities better understand the potential for technology to put into application, that was the focus of my developing a case to test this on. So the focus was on energy for the reasons that I've stated here. Next slide, please. And then again, I had the opportunity, the good fortune of being able to use case studies from an area that I'm already working in. So what I'm showing here is the breakdown of our research portfolio in 2016. And we had a big chunk of our research into energy efficiency and demand response. So 26%, a quarter of our research investment was invested in those two areas. It was turned out to be very helpful for identifying issues with the research proposals that could be improved. So next slide, please. So within that, like I said, the area that I chose to focus on was in the demand side management or demand response area. And again, utilities are risk averse, so helping them to identify ways to reduce that risk was important, and this technology transfer score, this research, helps them to look at technology transfer potential differently and emphasize different areas of the research proposal, working with the team that can facilitate a successful application of the results. Next slide. So within the demand response area, here are some of the challenges and benefits of demand response at BPA. So as we're trying to sort of shape our curve, make our curve more predictable, the demand curve more predictable, demand response can help with peak load management. It can act as a within hour balancing reserve, and it provides a non-wire solution. So it's very expensive to install a new transmission line. And so if we can identify ways to different solutions as opposed to building out new transmission, that's certainly going to be a preferred option. And so for these reasons, demand response at BPA is important. Next slide, please. So how I selected the proposals to evaluate and do a case study, test my model on. I looked at 3 proposals from the current portfolio at the time. I wanted more mature technology, so the technology readiness level 8 or 9 suggests that that technology is ready to be put into application. And I chose case studies that spanned multiple research organizations. So there was one proposal with the university, another with a national lab. So I wanted to make sure that there was enough of a difference between them that that wasn't a factor to be considered. So it looked at how did I evaluate the different 21 or identify the different 21 success attributes? I looked at the individual research proposals. I had interviews with the principal investigators and the subject matter experts on the project, and I had the opportunity to actually reach out to the research organizations to see, how they managed through these 21 success attributes, if at all. So I had to anonymize it, and so ROI was not available for these 3 research proposals, so it wasn't used to compute the overall tech transfer score. So next we'll go through the different research proposals. Next slide, please. The first one was using energy storage for demand management response. So it was a 1 megawatt hour of storage. Like I said, it was going to be used for peak load. It could be used for peak load reduction, balancing, or for spinning reserves. And the research was being done with private industry and another regional utility partner. Next slide, please. The second proposal looked at demand response potential using heat pump water heaters. Again, same sort of options that can be used for heat pump water heaters as to assist with demand response. And this proposal was done by jointly by a university, a national lab, another collaborative partner, and a utility. Next slide, please. And then you actually may see this in some of the Fred Meyer stores that you go in. The third proposal looked at demand response for the individual components in supermarket refrigeration. So these are the coolers that are used at Freddy's supermarket, and you might notice that the lights go off in some of those freezers as if somebody hasn't walked by. So it has the motion sensors for light activation, but there's also potential for using the different components in the refrigeration system to, maybe you don't have to always keep the temperature set at freezing. You can adjust it. And so that research was done by a national lab, and then there was the industry participation. Next slide, please. So for each of the proposals, I looked at the individual success attributes and came up with an overall technology transfer score. So, like I said, I came up with these values here. By looking at the research proposal, could I find any of this information out of the research proposal, or did I have to look at talk with the subject matter experts that were involved in the research, or was it something that I needed to actually talk to maybe a contracting officer or others that were involved peripherally in the research to develop the evaluation, to do the analysis. And so what I did, so here are the individual weights, if you recall, under the value column. So organizational was 0.18. And then for the budget cost share, it had a local value of 0.24. And then when I looked at how much budget cost share on that first tech transfer proposal was being used, I went to my desirability curve to find the corresponding value. So in this case, it was 40. I don't remember what 40 equated to, but it may have been 50-50 cost share. And then I come up with a value for this attribute of 1.73, I believe that is. And how I came up with that was just multiplying the 0.18, 0.24, the value from the desirability curve to come up with that. And I went through similarly for the other success attributes, came up with my overall score of 37.61, and did the same for the second proposal and for the third proposal. And so out of all of these, based on the score, the top ranking proposal was the second one. So if you recall, that was the heat pump water heaters using as demand response. The next one was the refrigeration system with a score of 45.73, and then the proposal that had the least technology transfer potential was the battery storage. So what do we do with these numbers? What does this mean? Next slide, please. So I showed the highest and lowest, but it's important to point out that none of them really scored that great. If the highest potential is 100 and my best is 47, there are things that can be done to improve the score. So that was part of the analysis and things that an organization can do. But what I did find out is that the model, had we used this model at the beginning of the research proposal, when we brought these into our portfolio, it would have correctly identified that third project as being, that first proposal, the battery storage proposal, as being one that we needed to watch more closely. And that's because of those three proposals, we ended up stopping that project because it didn't have a really good project management and communication going on within the team, so that it ended up being dropped from our portfolio. And so, and for those reasons, I said they had management support of the technology, but there wasn't very consistent engagement. So the model predicted the project that, in this case, ended up being dropped from our proposal. Next slide, please. So then I'm going to look at what could be done to improve the model sensitivity, how robust is the model, generalizable, and how these results can be used. Next slide. So I did looking at future-based scenarios. So what if I changed, excuse me, what if I changed the weights and made the individual perspectives the most important? How would that affect my overall results? So recall the market was the most expensive. Market was the most important perspective, and these were the results of proposal 1 had the least potential, proposal 2 had the best, proposal 3 was next best. And so what if I changed the organizational to be most important? I can see that the results of the proposal don't change. And then similarly, if I made technological perspective most important, or the social. But you'll see for the social, the proposal 1 still was identified as had the least potential, but proposals 2 and 3 switched. Next slide, please. The sensitivity analysis identified that the model was sensitive to changes in the social perspective, and that's what I identified on the previous slide, showed that the switch was from proposal 2 to proposal 1. Excuse me, proposal 2 to proposal 3. Okay, next slide, please. So then I wanted to make sure that the model could be applied to other types of research rather than just demand response. So could I look at really any technology and see if that applied? So I was able to use it on some transmission related projects in our portfolio and looked at, again, my criteria was to look at higher TRL projects and the participants in the research were by universities and other utilities. And so this just shows the transmission research project that I was looking at, which was basically to achieve a more optimized grid, that they actually replicate what was going on, the models that were being used, that they actually replicate what was going on the system. And what this allows transmission to do is they can push their system operating limits, their SOLs. So rather than operating at a very conservative level, having a better picture of what's going on at the system allows them to be less conservative and increase their system operating levels. Okay, next slide, please. So I did the robustness, tested the robustness of the model on that particular technology, and we could use all of the success attributes, and that verified that the model could be used for any type of technology. Next slide, please. So this is, okay, how can we use this model? What information can we take away and apply? And so how can we improve the scores? So like I said, they're not at 100% or 100, score of 100. So what areas could we use to improve? So looking at the areas here, we can see that the stakeholder complexity is an area for improvement because, again, this ranked highest in the organizational perspective. So we wanted to focus there, not technical necessarily, because that ranked pretty high. It was 83, 183. But because technical and stakeholder complexity is the highest, we wanted to make sure we looked at this area. So for all three of the research proposals, they didn't score so well, especially proposal number 3. So if we wanted to increase the technology transfer potential for this proposal in the area, we could see what we could do about managing the stakeholders' engagement better. Similarly, for the social aspect, the highest ranking success attribute there was how many people are we going to dedicate to the tech transfer effort? And across the board, we could see very low scores here. So that would be another area to focus on in the research proposal to improve the overall tech transfer scores. In the technological area, the highest ranking was the technology benefits, and we can see across the board those scores are pretty good. And then from a market perspective, the level of top management interest, so making sure that executives are on board, have an awareness of what's coming, was identified as the most important success attribute, and we can see that there's room for improvement in that area. So by identifying these 3 areas as potential areas to focus on to increase the technology transfer potential, it would be good to focus in on these areas. Next slide, please. So doing that, I looked at, here we have in Proposal 1, the original success attribute score is shown here, 37.1. And these are the different areas that we said, hey, if we can improve the scores there, that's going to improve the overall score. So let's say for Proposal 1, it currently has 3 pretty significant stakeholders. What if I were able to just maybe involve less people? Maybe that's a practical option for that individual project. So if I was able to reduce the number of stakeholders to 2, if I had more people dedicated, because right now I think that's a half of a person dedicated to tech transfer activities, if I could dedicate a whole person, and if I could even make sure, so the original proposal, there was some interest by middle management, but if I could increase that awareness and get executives aware and not even having them consistently aware, if we were just to increase their awareness, our overall score would increase by 6.4%. And similarly, if I did the same with, less stakeholders, making sure that there are quite a few people dedicated to tech transfer, making sure that executives are fully engaged, I've increased my score by 33%. So similarly, you can look and apply that same logic to proposals 2 and 1. But basically, what this is it helps to get the conversation started. So let's say of the 3 proposals, I really was interested in the technology for Proposal 1. And from a technology perspective, that looked like something I really wanted or would recommend to put into the research portfolio. By evaluating the score up front, I could see areas at the very beginning of the research proposal where I would need to focus. And for the Proposal 1, which was the battery storage proposal, it was the project team, it was the communication to executives that caused that project to be dropped from our portfolio. So I would have seen that early on by asking the question of what is the level of top management interest in this project, and how can we keep them engaged? So the model, by developing the scores, can start the conversation about where do we need to focus efforts at the beginning of a project to better have a better potential for successful tech transfer. Next slide, please. So this is just showing a summary of my analysis. It's sensitive. The highest ranking perspective was market, and that is contradictory to how research organizations are evaluating research proposals. That Proposal 2 and in fact, Proposal 2 had the highest score, and it was appropriate because it had the best communication plan out of all of the research proposals that were evaluated. The model is sensitive to the social perspective, and that we were able to use the results and the success attributes to look at specific areas where at the beginning of research, we should maybe focus our attention to better ensure successful tech transfer. Next slide, please. So my research confirmed that it really is an interaction, that relationship building that really contributes to successful technology transfer and ultimately supports what I identified as literature as being important for successful technology transfer. Next slide, please. So I feel that this model is something that can be used by an R&D organization. I mean, even if they don't go through and calculate a score for each proposal, it really helps them to to identify areas where they need to focus attention on. Just because the model has been prioritized by experts, they can easily see that the market and building that relationship is most important. And within each of the different perspectives, we've prioritized the most important success attributes, so an organization can focus energy there if they feel that there is some shortcomings, if there are some shortcomings. It quantifies attributes, so rather than just looking at them qualitatively, you are able to take the time and develop really a score for each of the different proposals. And if you, that can be used as, if you only have a certain amount of money to be allocated to, say, demand response projects in this case, you want to pick the proposals that have the best potential for successful technology application. And so this is just a complement to what research organizations already consider as part of their research proposal process. Next slide, please. There's a question. So Chip was asking if there were perspectives of safety or environmental. I'm going to open up chat. Or environment considered. So let me go back. So Chip, if that's okay, I'll wait till the end to answer your question, and we can go back and look at the individual perspectives, the 21. Okay, so again, here is the practical application, the contributions of this research. And I've included, again, market perspective, most important. Within that, you want to focus on what's the return on investment, and making sure that you have top level management engaged as part of the tech transfer process. And I included some quotes from my evaluation process from my subject matter experts. And I can't see them so well because I have chat open. But it's really about creating that technology pull and making sure that the ultimate transfer requirements are understood and that there's a significant commitment. So as I was going through the validation piece of my research, these were quotes that came from my subject matter experts to confirm that why market was most important. And I would even say that within BPA now, our framework for managing research is a little bit different than we have done in the past, but our executives have been very, very clear. Since our executives have been very, very clear that the benefit to BPA has to be very clearly understood, articulated at the beginning of the research project. As well, there has to be an understanding of, okay, how are we going to move? How are we going to do the research? And then once the research is complete, who's going to be receiving the technology? What does that transfer look like? And how do we measure its effectiveness afterward? So that whole kind of technology transfer process has become very, very important to our executives. And so our revised process has taken a concentrated, very specific look at how we can achieve successful tech transfer. And so I'm able to use some of these elements of understanding successful technology transfer potential as part of our revised process. And I would say one example is that I have a dedicated technology transfer manager who takes these success attributes, who's developed a research, or who has developed a technology transfer framework so that we can start looking at those aspects as part of the research effort and then track results when the research is complete and transferred into the organization. Next slide, please. And again, this just goes through some of the examples of the individual perspectives and what the researchers how they can use the information from that different perspective, and then quotes that complement what I'm stating above. Next slide, please. And then similarly here, for project meetings, literature suggests, oh, I'm sorry, go ahead. Thank you. So literature suggests, can you go back, Dr. Diane? Thank you. Literature suggests that there has to be frequent and effective project meetings. It's going to make sure that there's that dialogue and trust between the researcher and the tech recipient. And then you start thinking, you identify those barriers through these conversations of, I never thought about that, or had we considered this? And so those type of questions are sort of a natural fallout of having frequent communication between the researcher and the tech recipient. And again, quotes that support my what I'm stating above. Next slide. And then similarly from the organizational perspective. Next slide, please. So yes, they emphasize, the research organizations emphasize the technology perspective in their evaluation process, but their criteria doesn't quantify or prioritize any of the attributes that were identified in my research. And then how this can be used is that the score can help to inform a decision. It is not an absolute measurement, or should not be, the absolute decision criteria for bringing in a proposal to the portfolio, but it can be used as data and inform the decision. Like I said, maybe you really wanted that first research proposal, battery storage, to be in the portfolio. It identified areas of weakness that you could improve the overall score, and then kind of focus attention there to make sure that the likelihood of tech transfer was better. Next slide, please. So there are limitations to this model. It's deterministic. We didn't look at the probability of success or any other risks. And again, it's not an absolute. It should just be used to inform the research process. There are many other things that should be taken into consideration. And like Kurt was asking, maybe there are safety things that need to be considered. Maybe there's a reason why we can't install battery storage and we need to focus more on heat pump water heaters as a demand response potential. So there are other things that should be taken into consideration. The emphasis being that this is not an absolute element of selecting a research proposal. Next slide, please. So future research opportunities is to test this with other organizations. And like I said, we are using this model to a certain extent in our revised process at BPA. And we will be restarting our funding opportunity announcements in the spring. And so our adjusted solicitation criteria will reflect these success attributes. Again, the challenge, though, might be access to the information through research proposals or the organization. I see that one of the criteria, success attributes, was to have diversity training, because you're dealing oftentimes with multicultural organizations and project teams, and so how to effectively participate and contribute to project teams. The literature suggested having diversity events. And so some organizations don't have any. And how do we accommodate that if that's going to be an issue with the research proposal? And so it might be difficult, and it might be time consuming to get some of the information out of the organization. So that's a limitation. Next slide, please. And that's it. So Dr. Diane, could you go back, please, to my model so we can address the question directly? Thank you. So Chip had a question of, were the perspectives of safety or environmental considered? And they were not specifically addressed in this model. They would likely be part of the technology piece, the technology element of the research proposal. So we looked. These were under technology. Looked at the combined research experience. Are there lots of? Is there lots of information available about the technology, which is the number of publications? How many people are assigned to the tech transfer effort? What are the benefits of technology? So that is where it would be included, but it's not specifically. I would think that would be the most likely area where safety or environmental would be captured, but it's not specifically or explicitly addressed in the model. And then just for reference, the other aspect under technological is how much budget is allocated to the tech transfer effort. So you had another question, Chip, about how about a complete paradigm shift? What if we eliminated the grid and used distributed generation using rooftop solar? So are you asking, could this model be used to understand if we could use distributed generation for rooftop solar cells?
Yeah, if you don't mind, I'll speak up. And
Sure.
So the safety and environment are I think, though they're not explicitly explained in this model here, in general, there seem to be unusual perspectives that are considered or may have a big impact. And yet, in the energy industry in general, right now we're working under a fairly arcane model with a central power generation distributing my lines elsewhere. And yet there's the clear potential that there could be a phenomenal shift where the whole thing gets thrown on its head. And that would have I suspect it would have a radical impact on any decision that an administration would want to consider.
I would agree. So for the safety and environmental, I would think that would be captured in the benefits. So there is a benefit to do the research project if it improves safety, and there would be a technology benefit that would score high if there is an environmental component that needs to be addressed. So again, not explicitly addressed in my model, but it would likely come under the technology benefits. Your second question about a paradigm shift of using more distributed generation. So I would say that this model is not intended to look at paradigm shifts. It's intended to look at the research proposals that might address those paradigm shifts and helping to pick the right ones.
Thank you
so
much.
Yeah,
go ahead.
Or the ones that would suggest the highest tech transfer potential.
Judith, thank you so much for this lecture and covering it with this detail. And we will post this soon to LinkedIn. and you may get more people interested in it, hopefully.
Okay.
And this basically ends our lecture for today. Thanks everyone for joining us.
Thank you.
Bye-bye.
Thank you. Bye.
Thank you. Bye.